Hi, this is Hai Xiaowang, and today we are going to talk about PathSum 3. And given the root of the binary tree and an integer target sum, returns the number of the passes, where the sum of the values along the path equals to the target sum. So let's just go through the example 1 quickly. And given the binary tree like this, and there are three valid paths that if we sum it up, it's equal to the target sum, which is 8. The first one is 5 plus 3, and the second path is 5 plus 2 plus 1, and third is minus 3 plus 11. So there are three passes that equal to target sum, and we are supposed to return 3. Actually, this is a prefix sum problems, and I will show you the basic idea of it in one theory. Then there's an element list, which is E1, E2, E3, E4, blah 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 onto E10. And there's a prefix sum array, and it's equal to P1, P2, P3, P4, blah 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 blah, P10. For pi in the prefix sum list, which means and it means the first I element total sum that equals to the pi. For example, P3 here is equal to E1 plus E2 plus E3, and P10 is equal to E1 plus E2 plus E3 plus E4 plus E5 plus E6, blah blah blah, until we plus it to E10. And if we want to find a subarray set, its total sum of the subarrays is equal to target sum, which means that so for example, if we there's a subarrays that from element 4 to element 10 is equal to target sum, which means that we can just P10 minus P3 is equal to this one, and is equal to the target sum. Yeah, yeah. And so it's really intuitive to think that if we can use a hash map to store the current sum informations, and every time we go to a new element, and we just update the current sum, and what we do is just to check the current total sum minus target sum. As a result of this, we are supposed to do is to check whether they are in the previous hash map. And if there is a number that is already in the hash map, which means that we are already find the valid path. So because we are supposed to return the number of it, so for the hash map, the key is current total sum, and the values is the frequency of the previous total sum. So here, if there's only one subarray in the list, so this should be only the is P3. And so we just updated the count variables by +1. And actually, this is just an idea behind the prefix sum. So let's just code it out. And for the dfx functions, there are two parameters. One is the node, and one is the current total sum. The basic is that if not the node value is null, we just return. And the current, every time we visited a new node, we just update the current sum by plus that new node's values. And this is just, I'll just define it out of the function. We should initialize these values to be 0, and there is a previous, which is a hash map default dict, which is initialized with to be 0, and should be pass. So we want to check how many current sum minus target sum in the hash map, and if this kind of the value do not exist, it will return 0. So it's unnecessary to write if conditions here. And after that, we should update it the previous hash map by using the key, the current total sum by +1, and then we are supposed to start the recursion part. And after we doing down the recursion, we should exclude the current name from the past. So we should restore the situations here. For example, if we start from the 5, 3, -2, and if we want to go and do backtracking to 3, and the -2 should be excluded from the past, so we should update this -2 to be -1. And then this is just the recursion part. And we should be pay attention that corner case is that if there is a node that its values is just equal to the target sum, which means that there is a node that it only contains one node, which is itself. And we can also regard this kind of the path to be a valid path. So if it's in this case, so 0 should be 1. So if the current values, which is just the node values, and minus target value, which equal to 0, and the 0 should be 1 because it only has one node. So dfs root.0 and return. That's pretty much what its progress. Yeah, it works. Thanks for watching.